Okay, good morning, Year 9. This is a short introduction video to your work for today. Continuing our inheritance topic, we're looking at sex determination and genetic inheritance. So, your starter task, which is just a quick recall, is a short independent Kahoot quiz. So I'd like you to go onto Kahoot. The link here will be in Go for Schools, or you can go in and use this game pin. It's just an independent challenge, so you can practice that at any time, okay, but have a go at this before you continue with the work and see how you get on with those questions. Okay, so we're going to look at the issue of how we determine the sex of children. Basically, how do we know we get boys and girls? Okay, so this picture here shows you something called a karyotype. It represents all of your chromosomes, okay? And you'll notice that they are paired up and numbered 1 to 22. At the bottom here, we have two chromosomes called the X and Y chromosomes. And these are the sex chromosomes. These are the ones that determine whether the child is a boy or a girl, okay? So an XY chromosome indicates a male, two X's indicate a female, as we've seen already. So the question is, why, around the world, why is the ratio of boys to girls approximately 50-50? Why is there about the same number of boys as there are to girls? Well, it comes down to a number of things, and we're going to look at that in a second. So we know that humans have 23 pairs of chromosomes, okay? We know that, as I said, 22 pairs are similar. They have the genes that carry all the information about the different characteristics of your body. Okay, your hair color, your eye color, all of those different bits of information. One pair, as I've just said, determine the sex of the offspring. So in human females, they are XX. In human males, they are XY. So if a baby has an XY chromosome, we know it's a male. If it has XX, we know it's a female. And those chromosomes, when the cells divide through meiosis, will obviously be passed on to the offspring. So we're going to look at how we calculate that probability, okay, using something called a Punnett square. I'd like you to follow me through this. So I'd like you to pause and draw what's on the screen now into your books. Okay, so we're representing here the father and the mother in process of fertilization to see what offspring we end up with. So we can see that the father has two chromosomes, the X and the Y, okay, and the mother has an X and an X, okay. And when cell division takes place, well, when crossing over and chromosomes start to join up, there can be all sorts of mixes going on, okay, because remember we end up with 4 different daughter cells, okay, which can all have a mixture of different types of chromosomes. So what can happen is these boxes here represent the 4 possible options that we might end up with, the 4 possible combinations of chromosomes that we could end up with in our daughter cells, i.e. in our new embryos, okay, when fertilization takes place. Doesn't mean that if two parents have 4 children, these are the children they're going to have, but it's the 4 possibilities for each child. So with the first possibility, okay, we could have this X chromosome from the father and this X chromosome from the mother. And what that would give us would be 2 X chromosomes. Now I'm not going to draw arrows across all of this because it will become messy, but you'll get the idea. In this box here, we could get an X chromosome from the mother or a Y chromosome from the father this time, because this is coming this way. In this box here, this option is an X chromosome from the mother and an X chromosome from the father. One from the top, one from the side. And then in this final box here, we could end up with an X chromosome from the mum and a Y chromosome from the dad. Okay, I'm just going to draw an arrow here to show that that's coming in there. So hopefully that's nice and clear. Now what does that mean? is that we've got those 4 possible options. Okay, and you can see that 2 of them are the same, and these 2 are the same. So we have 2 XX offspring and 2 XY, the same number. Now what do we know? An XX is a female. And we know, we've just discussed, that an XY is a male. So therefore, in any combination, for any offspring, we will always have the same potential number of boys and girls, females and males. There is what we call a 1-to-1 ratio, or a 50-50 split, or it is of course 2-to-2. So that's what we would end up with in our Punnett square. Okay. Now, so a quick question for you to think about. Okay, so a couple are expecting a baby. They already have a daughter. What is the probability that their next child will also be a girl? Okay, explain your answer. Pause the video and have a go at this question. Have a think. Okay, so the answer is 50% or 0.5 or 1-to-1. Okay, if I go back to this, I should have mentioned that as well as being a 1-to-1 or a 50-50, this is a 50% chance. Okay, so and the reason for that is that because all egg cells will contain an X chromosome, so it's always going to be, but 50% of the sperm cells will also contain an X chromosome, so there's always the same probability. It doesn't matter how many children you've had in the past, there's always the same probability. So a couple of bits of information for you to write down. You have 2 copies of every gene, one paternal and one maternal. Your genes can vary slightly from each other, so you can either have 2 exact copies or you can have 2 that is slightly different. Something called an allele, which is a different version of the same gene. So on each of those chromosomes, you'll have the same gene, but 2 different copies of it. So when we're going to use, just as an example, we're going to use the same principles that we've just seen for determining boys and girls to determine some other characteristics. And in this example, we're going to look at dimples in our cheeks. So what that means is the dimple for alleles, the allele for dimples is dominant over the alleles for no dimples. That means if somebody has dimples as one of their on their chromosomes, then their offspring are going to have dimples. Now we're going to apply the same principles that we've just done to this example here. So I'm going to use the same method, and I'm going to show that this comes from here and this comes to here. Now when we represent these, we normally put the capital letter first, regardless of where it's come from. Okay, even though that large D has come from here and the little d's come here, we normally put the large D first. We get the same situation here, we get the same situation here, and we get the same situation here. So in this case, where mum does not have dimples, dad does have dimples, and he has two alleles that are the same, 2 genes on his chromosomes that are the same, he ends up with 4 identical offspring, okay, in terms of dimples. So he ends up with 4 that are DD, and because the big D is what we call dominant, okay, so that if a big D appears, that means they all have dimples. So we are going into some complex areas where we've not touched on some certain terms yet, okay, but I just want you to get the idea of how to do these crosses first of all, before we worry too much about what it actually means. That's what it looks like, and as I say, I've drawn it there to show how it would do, but we normally represent with the large D first. So what I'd like you to do, guys, today is have a go at this worksheet. Okay, so this worksheet talks about some terms that we've been mentioning, but also some that you may not be quite so familiar with. Okay, but I want you to have a go at the Punnett squares and see how you get on. Just completing them and seeing the ratios and the numbers, doing the maths for it, rather than worrying too much about the wording for the moment. Okay, so that's your independent work for today, is to work through the worksheet that is on Go for Schools for you. Okay, right, good luck with that, and I will set an assignment up for you to upload it to. Oh, and finally, there is some consolidation work on Seneca. If you go into Seneca and click on to find the course that's assigned to you, the Combined Science Biology course, I'm not sure whether you have Foundation or Higher assigned to you, but go and complete the following sections. So 1.2, which is about cell division, and then sections 6.1.1 through to 6.1.5, which is about reproduction and genetic inheritance. Okay, that should not take you too long. Good luck, and I'll see you soon.